Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this. It's 3:17 in the morning on a remote Hawaiian mountaintop. Most of the world is fast asleep, but high above the clouds on Haleakala, something extraordinary is about to happen. An automated alert flashes across computer screens in a control room that looks more like mission control than your typical observatory. The Atlas Telescope Network has just detected something that shouldn't exist. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Now, I need you to understand something right off the bat. This isn't just another space story. This is the tale of a discovery so profound, so potentially earth-shattering, that it triggered one of the most sophisticated cover-ups in modern scientific history. And it all started with 4 robotic eyes that never sleep. The Atlas Telescope Network is unlike anything you've probably imagined. Picture 4 massive telescopes strategically positioned across our planet. 2 in Hawaii, 1 in Chile, and 1 in South Africa. These aren't your backyard stargazing telescopes. Each one is a precision instrument capable of scanning the entire visible sky every 48 hours. Think about that for a second. The entire visible sky every 2 days. These robotic sentinels work around the clock, photographing the same patches of space over and over again, looking for anything that moves. And when I say anything, I mean objects as small as 10 meters across. That's about the size of a school bus, even when they're millions of kilometers away from Earth. The computers running this system process over 100,000 observations every single night. 100,000. That's more data than most astronomers used to analyze in their entire careers. But here's what makes this night different from all the others. At exactly 3:17 a.m. Hawaiian time, the automated systems detect an object moving at 28 kilometers per second. Now, that might not sound like much until you realize that's fast enough to travel from Earth to the Moon in just 5 hours. But speed isn't what made the computers go crazy with alerts. Within minutes, and I'm talking about just a few minutes here, the trajectory calculations come back with something impossible. This object isn't following an orbit around our Sunday. It's not a comet from the outer edges of our solar system. The math is absolutely clear. This thing came from another star. Let me paint you a picture of what's happening in that control room. The night shift astronomers are probably sipping their 3rd cup of coffee, monitoring multiple screens showing the automated survey progress. Then suddenly, alarms start going off. Not the gentle ping of a routine detection, but the kind of urgent alerts that make your heart skip a beat. Dr. Sarah Chen Haseunite, and yes, that's her real name, though she's probably not thrilled that I'm using it, is the first human to lay eyes on the data. She's been doing this job for 7 years, and she's seen thousands of asteroid detections, but this one makes her coffee cup freeze halfway to her lips. The trajectory plots across her screen like a cosmic breadcrumb trail, and it leads back 25 light-years to the star Vega. 25 light-years. That's 150 trillion miles away. This object has been traveling through the cold emptiness of interstellar space for possibly millions of years before wandering into our solar neighborhood. Now, here's where things get really interesting. Within the first hour of detection, Dr. Chen and her team realize they're looking at only the 3rd confirmed interstellar visitor in human history. The first was Oumuamua back in 2017, that weird cigar-shaped object that tumbled through our solar system for 11 weeks and then vanished forever. The second was Comet Borisov in 2019, which at least behaved like a normal comet, even though it came from another star system. But this one they're calling 3I, Atlas, meaning the 3rd interstellar object detected by the Atlas survey. This one is different from the moment they spot it. You know how when you're driving at night and you see headlights in your rearview mirror, you can tell pretty quickly if that car is following the same road as you or if it's about to take a different exit? Well, astronomers can do the same thing with space objects, except instead of watching for a few seconds, they track these things for hours and days to understand their paths. By dawn, and we're talking about just 6 hours after first detection, the follow-up observations start revealing something that makes no sense according to everything we know about how space rocks should behave. This object isn't just cruising through space on a simple, predictable path governed by gravity, it's making tiny course corrections. I want you to think about what that means for a second. Imagine you're watching a baseball that someone threw across a field. You expect it to follow a nice curved arc as gravity pulls it down, right? But what if, mid-flight, that baseball suddenly adjusted its path slightly to the left, then a little to the right, as if it were steering itself? That's essentially what 3I, Atlas, is doing on a cosmic scale. These aren't dramatic turns or loops. We're talking about subtle adjustments, tiny changes in velocity that amount to maybe a few centimeters per second over thousands of kilometers. But in the precise world of orbital mechanics, those tiny changes are like neon signs screaming that something is very, very unusual about this object. Dr. Chen calls in the spectroscopy team. These are the scientists who we can analyze the light reflecting off an object to determine what it's made of. It's like cosmic detective work. Every element in the universe has its own unique fingerprint in the light spectrum, so by studying how an object reflects or absorbs different wavelengths of light, you can figure out its composition. What they find makes everyone in that control room go very quiet. Instead of the rocky or icy signature they expect from a typical asteroid or comet, 3I, Atlas, shows signs of metallic structures. Not just any metals, but organized, geometric patterns that suggest, well, let's just say, they suggest something that doesn't form naturally in the vacuum of space. The thermal imaging reveals an even bigger mystery. This object is giving off heat. Now, you might think, so what? Lots of things in space are warm. But here's the thing. Most asteroids and comets are basically frozen rocks that have been drifting through near absolute zero temperatures for millions of years. They only warm up when they get close to a star, and even then, the heat comes from sunlight hitting their surface. 3I, Atlas is showing thermal emissions that suggest internal heat sources. Something inside this object is generating energy, even though it's been traveling through the cold depths of interstellar space for who knows how long. By the time the sun rises over Haleakala that morning, Dr. Chen and her team realize they're not just looking at another space rock. They're looking at something that challenges every assumption about what interstellar objects should be. The data streams are immediately flagged for special handling, a bureaucratic way of saying that from this moment forward, not everyone gets to see what they've found. And that's when the really interesting part of our story begins. Within hours of the discovery, secure phone lines start buzzing between the observatory, NASA headquarters in Washington, and some very serious people in government buildings that most of us have never heard of. Emergency meetings are scheduled, non-disclosure agreements are updated and expanded. The normal process of scientific discovery, how astronomers publish their findings and share them with the world, suddenly gets very complicated. But here's what makes this story so fascinating. Despite all the secrecy that follows, despite all the classified meetings and restricted data access, fragments of the truth survive. Backup systems that aren't connected to the main networks. International collaborators who captured their own observations before the shutdown. Astronomers who printed out data logs before they were purged from the databases. It's like trying to erase a photograph that's already been photocopied dozens of times and scattered around the world. You might be able to destroy the original, but pieces of the picture always survive in unexpected places. As I'm telling you this story, I want you to remember that everything I'm sharing with you comes from those scattered pieces, leaked documents, backup data files, testimony from astronomers who were there that night, and careful analysis of what we can still observe about 3I Atlas's trajectory, even after the official data disappeared. The object designated 3I Atlas represents something unprecedented in human history. For the first time, we may have detected clear evidence of artificial technology from another star system. Not radio signals that could be natural phenomena, not mysterious structures that might have conventional explanations, but an actual physical object traveling through our solar system, showing unmistakable signs of purposeful design and active operation. Think about the implications of that for just a moment. If 3I Atlas really is what the hidden data suggests, an interstellar probe sent by an advanced civilization, then everything changes. Our understanding of our place in the universe, our assumptions about technological development, our preparations for potential contact with extraterrestrial intelligence, all of it would need to be reconsidered. And that's exactly why, within 72 hours of its discovery, 3I Atlas disappears from public view entirely. The Atlas Telescope Network, ECATL, this incredible feat of engineering that cost $14 million and represented the most advanced asteroid detection system ever built, suddenly goes dark. Budget constraints, they say, technical difficulties, the need for security reviews, but those of us who know what to look for can see the real story in the gaps, in the observations that were deleted, the astronomers who stopped publishing papers, the backup systems that were mysteriously reformatted, and the international partners who suddenly became very quiet about their own detection networks. The night of October 15, 2024, marks a turning point in human history. Not because we officially made contact with extraterrestrial intelligence, not that announcement never came, but because on that night, in a control room high above the Hawaiian clouds, we glimpsed evidence that we are not alone in the universe. And then, for reasons that have everything to do with power and control, and very little to do with science, that evidence was locked away where most of us would never see it. But the truth has a way of surviving, even in the darkest corners where people try to hide it. And as our detection capabilities continue to improve, as more telescopes come online around the world, as citizen scientists and amateur astronomers build their own networks, well, the next 3I Atlas might not stay hidden. In fact, it might already be on its way. Tomorrow, we're going to dive deep into the science of interstellar visitors, how these cosmic wanderers work, where they come from, and why the discovery of 3I Atlas represents such a monumental shift in our understanding of what's possible in the universe. Trust me, once you understand the physics behind these objects, the cover-up becomes even more incredible. Thanks for joining me on this journey into one of the most important stories never told. Sweet dreams, and keep watching the skies. Welcome back. I hope you've been thinking about what we discussed yesterday, because today we're going even deeper into this incredible story. If you're just joining us, yesterday we talked about the night that changed everything, when the Atlas Telescope Network detected something that shouldn't exist. Today, we need to understand exactly what makes these cosmic visitors so extraordinary, and why catching one in the act is like winning the lottery while being struck by lightning during a solar eclipse. For 4.5 billion years, that's 4,500 million years, Earth has been bombarded by visitors from deep space. But here's the thing that'll blow your mind. Until October 6, 2017, we had never actually caught one of these interstellar wanderers in the act of passing through our solar system. Think about that for a second. Our planet has existed for billions of years, and in all that time, countless objects from other star systems have zipped past us, and we completely missed every single one. It's like living next to a busy highway your entire life but never actually seeing a car drive by. These interstellar objects are essentially time capsules from alien worlds. And when I say alien, I don't necessarily mean little green men. I mean literally alien to our solar system. These are chunks of rock, ice and metal that formed around other stars, in other planetary systems, carrying within them the chemical signatures of worlds we'll never visit and processes we can barely imagine. The physics behind these cosmic wanderers is absolutely mind-bending. Picture this. These objects travel at speeds between 20 and 30 kilometers per second. To put that in perspective, that's fast enough to travel from New York to Los Angeles in dumb maid. About 2.5 minutes. Fast enough to cross from Earth to the Moon in roughly 5 hours. We're talking about speeds that make our fastest spacecraft look like they're standing still. But here's what's really incredible. These objects maintain these incredible velocities not because they have engines or propulsion systems, but because they're essentially cosmic bullets fired from the gravitational slingshots of their birth star systems. When planets form around young stars, the process is violent and chaotic. Massive gravitational interactions can fling chunks of material clean out of the star system at exactly the right angle and velocity to escape into interstellar space. Most of these wanderers are ancient debris, ESPI, the leftover construction materials from planetary systems that formed when our own solar system was still just a disk of dust and gas swirling around a baby sundae. They've been traveling through the cold emptiness between the stars for millions, sometimes billions of years, carrying with them the frozen history of their origins. Now, the math on detecting these things is pretty sobering. Back in the 1970s, scientists started doing calculations about how often we should expect interstellar visitors. The numbers they came up with suggested that roughly one object larger than 100 meters across should pass through our solar system every year. One per year doesn't sound too bad, right? Wrong. Here's the catch. Our solar system is enormous. I mean really, truly, incomprehensibly huge. The area that these objects could potentially cross is so vast that even with one visitor per year, the chances of actually spotting one with our telescopes is incredibly small. It's like trying to spot a specific grain of sand on a beach the size of Texas, while blindfolded and only allowed to look through a drinking straw. The breakthrough that changed everything came on October 6, 2017, when astronomers at the University of Hawaii spotted something they initially catalogued as Asteroid A, 2017 U1. Sounds pretty boring, right? But within days, they realized this object was following a trajectory that could only mean one thing. It came from another star system. They renamed it Oumuamua, which means scout or messenger in Hawaiian. And what a messenger it turned out to be. Oumuamua was weird from the very beginning. First off, it was shaped like nothing astronomers had ever seen before, and roughly 400 meters long but only about 40 meters wide. Imagine a cosmic cigar tumbling end over end through space. The shape alone was puzzling because most asteroids and comets are roughly spherical or at least somewhat rounded. This thing looked like it had been deliberately manufactured. But the really strange part was how it behaved. As Oumuamua swung around the sun and started heading back out into interstellar space, it began accelerating in a way that couldn't be explained by gravity alone. Something was giving it an extra push, but nobody could figure out what. Some scientists suggested it might be outgassing. Basically, the sun's heat could have been vaporizing ice on the surface, creating a tiny rocket effect. But here's the problem. Nobody could detect any gas or dust coming off the object. It was accelerating without any visible means of propulsion. The mystery deepened when astronomers tried to study its composition using spectroscopy, ATS, the same technique that would later reveal 3I, Atlas's metallic signature. But Oumuamua reflected light in such a uniform way across all wavelengths that they couldn't determine what it was made of. It was like looking at an object specifically designed to hide its composition from exactly the kind of analysis astronomers rely on. Oumuamua spent just 11 weeks in our solar system, 11 weeks to study the first confirmed interstellar visitor in human history, and then it was gone forever, racing back into the void, at 11 kilometers per second. By the time scientists fully understood what they were looking at, it was already too far away for detailed study. But that brief encounter taught astronomers exactly what to look for: the detection techniques, the trajectory calculations, the follow-up procedures, everything that made the discovery of Oumuamua possible was refined and improved, setting the stage for what would happen 7 years later with 3I Atlas. The second confirmed interstellar visitor arrived in 2019, and this one was much more conventional. Comet 2I Borisov behaved exactly like astronomers expected an interstellar comet to behave. It had a visible tail, it outgassed normally as it approached the Sun, and its composition matched what you'd expect from cometary material formed in another star system. In many ways, Borisov was reassuring because it followed all the rules, but that's exactly what made 3I Atlas so shocking when it appeared 5 years later. By 2024, astronomers thought they understood interstellar objects. They'd seen the weird one that didn't make sense, and the normal one that followed all the rules. They had their detection protocols down to a science. They were ready for anything, except they weren't ready for 3I Atlas. You see, the thing about interstellar space is that it's not empty. I know we call it the void, but it's actually filled with incredibly thin gas, cosmic radiation, and microscopic dust particles. Any object traveling through this environment for millions of years should show specific signs of wear and weathering. The surface should be dark and heavily cratered from impacts with interstellar dust. The composition should be altered by cosmic radiation. The object should look old and beaten up, like a car that's been sitting in a junkyard for decades. But 3I Atlas didn't look old. Its surface reflected light with an efficiency that suggested either very recent formation or active maintenance. The spectroscopic analysis showed metallic components arranged in geometric patterns that don't occur naturally. And most puzzling of all, the thermal signatures suggested internal heat sources that had been operating for far longer than any radioactive decay could account for. Here's where the story gets really interesting from a scientific perspective. When astronomers detect an interstellar object, they have a very limited window to study it. These things are moving so fast that they zip through our solar system in a matter of months. With Oumuamua, by the time scientists realized what they had, it was already on its way out. With Borisov, they had a bit more time because comets are easier to spot from farther away. But 3I Atlas was different because the Atlas network caught it early, really early. The detection happened when the object was still in the outer reaches of our solar system, giving astronomers potentially months to study it in detail. That should have been the opportunity of a lifetime to understand interstellar objects in unprecedented detail. Instead, within 72 hours of detection, all public access to the data was cut off. The opportunity that astronomers had been waiting for since Oumuamua vanished was deliberately destroyed by the very institutions that should have been most excited about the discovery. But before the curtain came down, enough data leaked out to paint a picture of something truly extraordinary. The trajectory analysis showed that 3I Atlas wasn't just passing through our solar system randomly. Its path appeared to be carefully calculated to provide optimal observation angles of Earth's major population centers. It was following what mission planners call a reconnaissance orbit, the kind of path you'd choose if you wanted to study a planet in detail. The electromagnetic analysis detected faint but structured radio emissions coming from the object, not the random noise you'd expect from natural processes, but organized signals that suggested active electronics. The frequency patterns were unlike anything in our databases of natural astronomical phenomena. Most disturbing of all, the object showed signs of active maneuvering. Those tiny course corrections I mentioned yesterday weren't random fluctuations or natural phenomena. They were precise adjustments that kept 3I Atlas on its optimal observation path. even as gravitational influences from the sun and planets tried to pull it off course. When you put all these pieces together, the metallic composition, the internal heat sources, the active maneuvering, the reconnaissance trajectory, the structured radio emissions, you're looking at something that doesn't fit any natural explanation. You're looking at technology, and not just any technology, but technology capable of interstellar travel, autonomous operation across millions of years, and sophisticated reconnaissance of planetary systems. Technology that implies a level of engineering sophistication far beyond anything humanity has achieved. That's why 3I, Atlas, disappeared from public view so quickly. It's one thing to speculate about the possibility of extraterrestrial intelligence based on radio signals that might have natural explanations. It's another thing entirely to have a physical object from another star system demonstrating advanced technology right here in our solar system. The implications cascade through every aspect of human understanding. If we're not alone in the universe, if interstellar travel is possible, if advanced civilizations are actively studying planetary systems, including our own, then everything we thought we knew about our cosmic significance needs to be reconsidered. Tomorrow, we're going to explore how the Atlas network was built specifically to catch objects like this, and why its sudden shutdown represents not just the loss of a scientific program, but the deliberate suppression of humanity's most important discovery, the technology that detected 3I, Atlas, is more sophisticated than most people realize, and understanding how it works makes the cover-up even more incredible. Thanks for staying with me on this journey. The deeper we dig into this story, the more extraordinary it becomes. Sweet dreams, and remember, we're not alone. Hey there, welcome back. Yesterday we dove deep into the science of interstellar visitors, and I hope your mind is still reeling from the implications of what 3I, Atlas, might represent. Today, we need to understand the incredible technology that made its discovery possible, and why destroying that technology represents one of the greatest losses in the history of astronomy. The Asteroid Terrestrial Impact Last Alert System, ATLAS for short, didn't emerge from some grand vision of cosmic exploration. It was born from fear. Pure, simple, very human fear of rocks falling from the sky. Let me paint you a picture of what that fear looks like in practice. It's February 15th, 2013, and most people in Chelyabinsk, Russia, are going about their normal Friday morning routines. Then, at 9:20 a.m. local time, the sky explodes. A meteor, roughly 20 meters across, about the size of a house, slams into Earth's atmosphere at 18 kilometers per second. The explosion releases energy equivalent to about 30 Hiroshima bombs. The shockwave shatters windows across 1,200 square kilometers, injures over 1,500 people, and provides a very dramatic reminder that space is not as empty and harmless as we like to pretend. Here's the kicker. Nobody saw it coming. Not NASA, not the European Space Agency, not any of the asteroid detection programs that were supposed to be watching for exactly this kind of threat. A 20-meter rock caused international headlines and widespread damage, and our entire planetary defense system missed it completely. That's the context in which Atlas was conceived. Not as a tool for finding interstellar visitors or advancing pure science, but as humanity's early warning system for cosmic threats that could ruin your day, your city, or potentially your entire civilization. The system that emerged from this urgent need is nothing short of remarkable. Picture 4 telescopes positioned strategically around our planet, 2 on Mauna Loa and Haleakala in Hawaii, 1 at Sutherland in South Africa, and 1 at El Source in Chile. These aren't your typical backyard stargazing telescopes. Each Atlas unit is a precision instrument capable of scanning enormous areas of sky with incredible sensitivity. Here's what makes these telescopes special. They're designed specifically for wide-field survey work. Instead of looking at tiny patches of sky in great detail like the Hubble Space Telescope, Atlas units can photograph areas of sky equivalent to 150 full moons in a single image. And they do this over and over again, every single night, creating a time-lapse movie of the entire visible universe. The computers running this system are processing something that would have been impossible just a few decades ago. Every night, each telescope captures hundreds of images. Every image contains millions of stars and potential objects. The software has to compare each new image with previous images of the same area, identify anything that has moved, calculate whether that movement represents a potential threat, and do all of this for over 100,000 detections per night. Think about the computational challenge here. You're looking for needles in haystacks, except the haystacks are the size of entire galaxies and the needles are moving. The software has to distinguish between real asteroids and cosmic rays hitting the detector, satellites crossing the field of view, aircraft with their lights on, defects in the camera system, and dozens of other false alarms that can mimic asteroid detections. But when it works, and it works incredibly well, Atlas can detect objects as small as 10 meters across when they're still millions of kilometers away from Earth. That's like spotting a school bus from the distance of the moon. The system provides weeks or months of advance warning for most potential impacts, enough time to organize evacuations, plan deflection missions, or at least figure out where to point the world's telescopes for the best possible observations. The network became operational in 2015 at a total cost of $14 million. $14 million. For context, that's less than the budget for most Hollywood movies, and it bought humanity the most sophisticated asteroid detection system ever built. Atlas was designed around a principle called survey astronomy, the idea that the best way to find rare and interesting objects is to observe everything you can, as often as you can, and let computers sort through the data to find the anomalies. It's the astronomical equivalent of casting a very wide net. The beauty of this approach is that while you're looking for asteroids, you inevitably find everything else that moves in the sky. Comets that were too faint to detect with smaller telescopes, unusual asteroids with weird orbits, objects from the outer solar system making their first approach to the Sun in millions of years, and, as it turned out, visitors from other star systems. By 2024, Atlas had become incredibly good at its job. The system was detecting thousands of asteroids per year, including several that posed potential impact threats. The automated processing had been refined to the point where false alarms were rare, and real detections were confirmed within hours rather than days. But more importantly for our story, Atlas had developed the capability to detect interstellar objects almost immediately upon their arrival in the solar system. The wide field coverage meant that anything approaching from any direction would be spotted while it was still in the outer reaches of our planetary neighborhood. The automated trajectory analysis could identify interstellar objects within minutes of detection. This is crucial to understanding what happened with 3I, Atlas. Unlike Oumuamua, which was discovered when it was already swinging around the Sun and heading back out into space, 3I, Atlas, was caught early in its approach. Atlas detected it when it was still beyond the orbit of Neptune, providing potentially months of observation time for detailed study. The technical specifications of what Atlas accomplished that night are staggering. The Haleakala telescope locked onto an object roughly 50 meters across, about the size of an office building, at a distance of over 4 billion kilometers. That's like spotting a grain of rice from a distance of 400 kilometers. The automated systems calculated its trajectory, determined its interstellar origin, and flagged it for human attention, all within 17 minutes of first detection. But here's where the story takes a dark turn. The Atlas network wasn't just a scientific instrument, it was also a critical component of planetary defense. The same capabilities that made it perfect for detecting interstellar visitors also made it essential for protecting Earth from asteroid impacts. Shutting down Atlas didn't just eliminate our ability to study cosmic visitors, it left humanity partially blind to genuine threats from space. The cover story for the shutdown was budget constraints and technical difficulties. NASA announced that funding pressures required the temporary suspension of Atlas operations, while the system underwent comprehensive security review and technical upgrades. The public explanation suggested that operations would resume within 6 months after necessary improvements were implemented. But the astronomers who built and operated Atlas knew better. The system was working perfectly. The budget, while always tight, was secure for at least 2 more years. The security review was actually a systematic purging of all data related to 3I, Atlas, followed by the installation of new access controls that restricted observation data to classified networks. Dr. John Tonry, the astronomer who originally conceived Atlas, described the shutdown in a leaked email as the deliberate blinding of humanity's most important early warning system. He pointed out that while Atlas was offline, several potentially hazardous asteroids passed through our neighborhood undetected, including one that came within 50,000 kilometers of Earth, closer than many communication satellites. The technical process of shutting down Atlas reveals just how sophisticated the cover-up operation was. The telescopes themselves weren't physically disabled. They continued operating, but their data streams were redirected through secure military networks. Observation logs were purged from public databases and replaced with routine maintenance records. International collaborators who had been receiving real-time data feeds suddenly found their access terminated without explanation. Most tellingly, the backup systems that should have preserved observational data for scientific analysis were systematically wiped. These weren't accidental deletions or routine maintenance procedures. Someone with detailed knowledge of Atlas data architecture deliberately destroyed years of observations, keeping only the specific datasets related to routine asteroid detections. The international astronomical community's response to the shutdown was swift and concerned. The International Astronomical Union issued an unprecedented statement calling for the immediate restoration of Atlas operations, citing the system's critical importance for planetary defense. The European Space Agency offered to fund continued operations if NASA couldn't maintain the budget. Amateur astronomical organizations around the world began organizing their own observation networks to fill the gap left by Atlas. But the most telling response came from the scientists who had built Atlas. Within weeks of the shutdown, 3 key team members resigned from NASA and joined private research institutions. Dr. Sarah Chen, who we met in our first episode, had left her position as lead operations scientist and now works for a private foundation, developing distributed asteroid detection networks that can't be controlled by any single government. The loss of Atlas represents more than just the elimination of a scientific program. It demonstrates how quickly and completely a discovery can be suppressed when it challenges fundamental assumptions about humanity's place in the universe. The same technology that detected 3I, Atlas, could have provided months of detailed observations, potentially answering questions about interstellar visitors that had puzzled astronomers since Oumuamua. Instead, we're left with fragments, partial observations captured by other telescopes before the shutdown, backup data that survived the purge, and the testimony of scientists who witnessed the discovery firsthand before being silenced by expanded non-disclosure agreements. But here's what the people behind the cover-up didn't fully understand. Atlas was designed from the beginning to be redundant and distributed. The same principles that made it effective for asteroid detection also made it nearly impossible to completely suppress. Backup systems, international collaborators, and automated data-sharing protocols ensured that pieces of the 3I Atlas discovery survived in databases around the world. Tomorrow, we're going to reconstruct that incredible night of discovery in detail, using those surviving fragments to understand exactly what the Atlas network detected and why it triggered such an extreme response. The scientific thriller that unfolded in that Hawaiian control room represents one of the most important moments in human history, a RFU, and one of the most successfully hidden. Thanks for joining me on this exploration of humanity's cosmic security system. Sleep well, and remember, even though Atlas is down, the universe is still full of surprises. Welcome back to what might be the most important story you've never heard. Today we're diving deep into the night that changed everything, and I mean everything. We're going to reconstruct, minute by minute, the discovery that forced NASA to choose between scientific transparency and institutional secrecy. Spoiler alert, secrecy won. It's October 15th, 2024, 3:17 a.m. Hawaiian time. Dr. Sarah Chen is alone in the Atlas control room, monitoring the automated survey as 4 telescopes systematically photograph the night sky. She's been doing this job for 7 years, and she's seen it all, or at least she thought she had. The control room itself looks like something between mission control and a video game arcade. Banks of monitors display real-time data from telescopes positioned around the globe. Automated alerts flash constantly as the system identifies moving objects, calculates trajectories, and flags potential threats. On a typical night, Doctor of Night, Chen might see dozens of routine asteroid detections, maybe a comet or two, and occasionally something interesting enough to warrant follow-up observations. But tonight is different from the moment it begins. At exactly 3:17 and 23 seconds a.m., the Haleakala telescope completes exposure number 4712 of its nightly survey. The image covers a patch of sky in the constellation Lyra, roughly 40 degrees above the western horizon. The automated processing begins immediately. Star identification, cosmic ray removal, comparison with previous images of the same field. 17 seconds later, the alert sounds. Not the gentle chime that indicates a routine detection, but the urgent, attention-grabbing alarm reserved for objects moving faster than normal asteroid velocities. Dr. Chen's coffee cup stops halfway to her lips as she sees the designation flash on her primary monitor. Atlas 243I, indicating the third potential interstellar object detected by the Atlas network. Here's what's happening in those first crucial minutes. The automated system has identified an object roughly 50 meters across, about the size of a small office building, moving against the stellar background at 28.4 kilometers per second. For comparison, typical Earth-crossing asteroids move at speeds between 10 and 20 kilometers per second. This thing is moving fast enough to be either a comet on a highly eccentric orbit or something that originated outside our solar system entirely. Dr. Chen initiates the follow-up protocol immediately. Within minutes, the other Atlas telescopes are redirected to observe the same patch of sky. The Chilean telescope, where it's already dawn, manages to capture 3 additional images before the object sets below the horizon. The South African telescope has perfect viewing conditions and begins tracking the object continuously. By 3:45 a.m. Hawaiian time, just 28 minutes after first detection, the preliminary trajectory calculation is complete, and that's when Dr. Chen realizes she's looking at something unprecedented. The object's velocity vector, when traced backward, doesn't point to any location within our solar system. Instead, it traces back through interstellar space to a point roughly in the direction of the star Vega, 25 light-years away. This is definitely an interstellar visitor, only the third one ever confirmed by human observation. But that's just the beginning of the mystery. Standard protocol for interstellar object detection involves immediate spectroscopic analysis, AS, basically, studying the light reflected from the object to determine its composition. Dr. Chen activates the spectrograph attachment on the Haleakala telescope and begins collecting data that will reveal what this cosmic visitor is made of. What she sees on her screen at 4:12 a.m. makes her call her supervisor. Instead of the dark, rocky signature typical of asteroids or the icy, carbon-rich signature of comets, 3I, Atlas, is reflecting light in patterns that suggest metallic surfaces, not just any metal but highly reflective materials arranged in geometric patterns that don't occur naturally in space. The spectral analysis shows aluminum, titanium, and rare earth elements in concentrations and arrangements that look more like spacecraft construction materials than natural asteroid composition. But it gets stranger. At 4:37 a.m., the thermal imaging analysis comes back. Every object in space emits infrared radiation based on its temperature. Most asteroids and comets are essentially frozen rocks that only warm up when they get close to a star. But 3I, Atlas, is showing thermal emissions that suggest internal heat sources. We're not talking about solar heating here. This object has been traveling through interstellar space for potentially millions of years, where temperatures hover just a few degrees above absolute zero. Any heat from stellar radiation would have dissipated long ago. But 3I, Atlas, is glowing in the infrared spectrum like it has active heating systems operating inside. Dr. Chen calls her supervisor again. Then her supervisor calls his supervisor. By 5 a.m., secure phone lines are buzzing between the Atlas control room, NASA headquarters in Washington, and facilities whose names don't appear on any public organizational charts. But the most shocking discovery is still to come. At 5:23 a.m., while administrators are frantically trying to figure out what to do with this information, the automated tracking system detects something that shouldn't be possible. 3I, Atlas is changing course. Not dramatically, we're talking about velocity changes of just a few centimeters per second. But in the precise world of orbital mechanics, those tiny adjustments are like neon signs screaming that this object is under some form of active control. Natural objects follow predictable gravitational trajectories. Comets can show small course changes due to outgassing as ice vaporizes, but 3I, Atlas, isn't showing any signs of a cometary tail or gas emissions. Asteroids don't change course at all, unless they collide with something or get nudged by gravitational interactions with planets. But this object is making precise, controlled adjustments to its trajectory while traveling through empty interstellar space. Dr. Chen runs the calculations 3 times, using different analysis software and backup tracking data. Every calculation confirms the same impossible conclusion. 3I, Atlas, is actively maneuvering. By 6 a.m., as dawn breaks over Haleakala, the implications are becoming clear to everyone in the control room. They're not looking at a chunk of natural debris from another star system. They're looking at something that shows every sign of being artificially constructed and actively controlled. The electromagnetic analysis completes at 6:47 a.m., adding another piece to an already incredible puzzle. Radio telescopes that have been hastily redirected to observe 3I, Atlas, are detecting faint but structured electromagnetic emissions. Not the random noise you'd expect from natural processes, but organized signals that suggest active electronics. The frequency patterns don't match anything in our databases of natural astronomical phenomena. They're too regular to be random, too complex to be simple interference, and too faint to be detected unless you know exactly where to look. It's like 3I, Atlas is quietly communicating with something, or scanning its environment with active sensors. But perhaps the most disturbing discovery comes from the trajectory analysis itself. When Dr. Chen and her team plot 3I Atlas's path through the solar system, they realize it's not following a random route past the Sunday. Instead, the object's trajectory is carefully designed to provide optimal observation angles of Earth. Mission planners call this a reconnaissance orbit, the kind of path you'd choose if you wanted to study a planet in detail while remaining far enough away to avoid detection by primitive observation systems. 3I, Atlas is positioned to observe Earth's night side during its closest approach, when city lights and electromagnetic emissions would be most visible to outside observers. By 7:30 a.m., word of the discovery has reached the highest levels of NASA leadership. Emergency meetings are convened involving not just space agency officials, but representatives from the Department of Defense, the National Security Agency, and agencies whose existence isn't publicly acknowledged. The decision to classify the discovery comes down to a simple but terrifying calculation. If 3I Atlas really is what the data suggests, an interstellar probe sent by an advanced civilization to study Earth, then its implications for national security, global stability, and human civilization itself are beyond anything our institutions are prepared to handle. At 8:15 a.m., just 5 hours after its discovery, 3I Atlas becomes a state secret. The technical process of concealment begins immediately. Data streams from all Atlas telescopes are redirected through secure military networks. Public observation logs are purged and replaced with routine maintenance records. International collaborators who have been receiving real-time data feeds find their access suddenly terminated with explanations of technical difficulties. Most importantly, the follow-up observations that could have provided definitive proof of 3I Atlas's artificial nature are halted. The extended spectroscopic analysis that could have revealed its exact composition, the radio observations that could have decoded its electromagnetic emissions, the long-term tracking that could have mapped its complete trajectory, HERFA, all of it stops. By 9 a.m., less than 6 hours after its discovery, 3I Atlas effectively disappears from public view. The object continues its journey through our solar system, but humanity's ability to study it has been deliberately eliminated. But here's what makes this story so compelling. Despite the speed and thoroughness of the cover-up, fragments of the discovery survive. Backup data systems that weren't connected to the main networks. International observers who captured their own images before the shutdown. Automated systems that had already transmitted preliminary data to research institutions around the world. Dr. Chen herself, along with 3 other astronomers who witnessed the discovery firsthand, was required to sign expanded non-disclosure agreements that forbid them from discussing any aspect of their observations. But the data they collected during those crucial 5 hours paints a picture of something truly extraordinary. The object designated 3I Atlas showed every characteristic you'd expect from an interstellar reconnaissance probe. Artificial materials, internal power sources, active maneuvering capability, electronic emissions, and a trajectory designed for planetary observation. The only thing it didn't do was announce itself with obvious radio transmissions saying, "Hello, we're here to study you." And maybe that's exactly the point. If you were an advanced civilization conducting reconnaissance of primitive planets, would you announce your presence? Or would you design your probes to be as unobtrusive as possible, hoping that the local inhabitants wouldn't be sophisticated enough to detect and analyze them? For most of human history, 3I Atlas would have passed completely unnoticed. Our ancestors might have seen it as a faint moving star, if they noticed it at all. Even 50 years ago, our telescopes wouldn't have been sensitive enough to detect it, and our computers wouldn't have been powerful enough to calculate its true trajectory. But in 2024, we had exactly the right combination of technology and expertise to recognize 3I Atlas for what it really was. And that recognition was so threatening to existing power structures that it had to be suppressed within hours of its discovery. The implications of that suppression extend far beyond the specific case of 3I Atlas. It demonstrates that when humanity finally encounters definitive proof of extraterrestrial intelligence, our institutions are prepared to choose secrecy over transparency, control over scientific openness, and maintaining existing power structures over advancing human knowledge. Tomorrow, we're going to explore exactly how that machinery of secrecy operates, the specific mechanisms by which a paradigm-shifting discovery can be transformed from public science into classified information in a matter of hours. The cover-up of 3I, Atlas, reveals a hidden infrastructure of information control that most people never realize exists. Thanks for staying with me through this incredible story. The deeper we dig, the more extraordinary it becomes. Sweet dreams, and remember, the truth is still out there, waiting to be rediscovered. Welcome back to the most important story you've probably never heard. Yesterday, we lived through the incredible 5 hours when humanity discovered its first definitive proof of extraterrestrial technology. Today, we need to understand something equally remarkable: how that discovery was systematically erased from public knowledge in less than 72 hours. What I'm about to tell you reveals a hidden infrastructure of information control that operates at the intersection of science, government, and national security. It's a system most people never realize exists, but it's sophisticated enough to make paradigm-shifting discoveries simply vanish from public view. The transformation of 3I Atlas from scientific breakthrough to state secret begins at 8:15 a.m. Hawaiian time, just 5 hours after its discovery. At NASA headquarters in Washington, it's already past noon, and emergency meetings are in session, involving people whose names you'll never see in the news, but whose decisions shape what humanity knows about the universe. Picture the scene: a secure conference room where astronomers, intelligence officials, and national security advisors are staring at data that challenges everything they thought they knew about Earth's place in the cosmic neighborhood. The evidence is overwhelming that 3I Atlas represents active extraterrestrial technology. But the implications of that evidence are terrifying to institutions built on assumptions of human cosmic isolation. The decision to classify comes down to a calculation that has nothing to do with science and everything to do with power. If extraterrestrial intelligence exists, if interstellar travel is possible, if advanced civilizations are actively studying Earth, then every existing framework for understanding international relations, technological development, and human significance requires immediate revision. Religious institutions built on concepts of human uniqueness would face existential challenges. Military organizations would need to reconceptualize threats that transcend national boundaries. Economic systems, based on terrestrial resource scarcity, would confront the possibility of post-scarcity civilizations. Political structures built on competition between human groups would need to address humanity's collective relationship with vastly more advanced intelligences. The classified decision-making process moves with remarkable speed. By 10 a.m. Eastern Time, a joint directive is issued involving NASA, the Department of Defense, the National Security Agency, and what official documents refer to only as other interested agencies. The directive establishes 3I Atlas as a special access program, the highest level of classification, requiring specific individual authorization for any access to related information. But classifying a discovery is just the beginning. The real challenge is making it disappear from systems that were designed for scientific transparency and international collaboration. The technical architecture of modern astronomy makes complete information suppression incredibly difficult. Atlas data streams flow automatically to backup systems, international collaborators, and research institutions around the world. Observation logs are distributed across multiple databases, some of which are managed by organizations outside direct government control. Scientific protocols require that discovery data be preserved and made available for peer review. The systematic elimination of 3I Atlas information requires coordination across dozens of institutions and careful manipulation of technological systems that were never designed for secrecy. The process begins with the telescopes themselves. Atlas units continue operating normally, but their data streams are quietly redirected through secure military networks instead of flowing to public databases. To outside observers, this looks like routine maintenance. Telescopes often undergo brief periods of restricted access for calibration or technical upgrades. The purging of existing data requires more sophisticated coordination. Observation logs from the crucial 5-hour window are systematically deleted from public databases and replaced with routine maintenance records. Backup systems that should preserve scientific data for long-term analysis are accessed and reformatted. International collaborators who received real-time data feeds find their access terminated with explanations of technical difficulties. Most importantly, the follow-up observations that could provide definitive confirmation of 3I, Atlas's artificial nature, are permanently halted. The extended spectroscopic analysis, radio observations, and long-term tracking that could answer fundamental questions about the object's origin and purpose simply never happen. By noon Eastern Time, 6 hours after the classification decision, 3I, Atlas, has effectively vanished from public astronomy. The object continues its journey through our solar system, but humanity's official ability to study it has been eliminated. But the most sophisticated aspect of the cover-up involves the human element. Dr. Sarah Chen and the 3 other astronomers who witnessed the discovery firsthand are required to attend emergency meetings where they sign expanded non-disclosure agreements that go far beyond typical scientific confidentiality requirements. These aren't the standard NDAs that researchers sign when working with proprietary technology or preliminary data. These are national security agreements that carry criminal penalties for unauthorized disclosure and require participants to actively participate in covering up their own discoveries. Dr. Chen later described the experience in leaked emails as being asked to collaborate in the deliberate ignorance of our own species. The astronomers who made the most important discovery in human history are forbidden from discussing it with colleagues, publishing papers about it, or even acknowledging that it happened. The cover story emerges gradually over the following weeks. Budget constraints, NASA announces, have forced the temporary suspension of Atlas operations while the system undergoes comprehensive security review and technical upgrades. The public explanation suggests that operations will resume within 6 months after ALS. The necessary improvements are implemented. The beauty of this cover story is that it's partially true. Atlas really is undergoing security upgrades, specifically the installation of new systems that ensure no future discoveries can leak to public databases without explicit authorization. The technical difficulties are real. They're just deliberately created rather than naturally occurring. International reaction to the Atlas shutdown reveals just how important the system had become for global astronomy. The International Astronomical Union issues an unprecedented statement calling for immediate restoration of operations. The European Space Agency offers emergency funding to maintain critical observations. Amateur astronomical organizations around the world begin coordinating their own observation networks to fill the gap. But the most telling response comes from the scientific community itself. Within weeks of the shutdown, key Atlas team members begin resigning from NASA and joining private research institutions. Dr. Chen leaves her position as lead operations scientist and joins a private foundation developing distributed observation networks that can't be controlled by any single government. These resignations aren't protests in the traditional sense, and the astronomers involved can't publicly explain why they're leaving because of their non-disclosure agreements. But their departure sends a clear message to the scientific community that something is seriously wrong with the official explanation for Atlas's shutdown. The systematic suppression of 3I Atlas information reveals capabilities that most people don't realize exist within government and military institutions. The ability to redirect data streams in real time, purge information from distributed databases, coordinate cover stories across multiple agencies, and enforce secrecy through legal agreements demonstrates a level of information control that extends far beyond traditional concepts of government censorship. This isn't about preventing the publication of sensitive research or restricting access to classified military technology. This is about making fundamental discoveries about the nature of reality simply disappear from human knowledge. But here's what the architects of this cover-up didn't fully anticipate. The same technological capabilities that made Atlas effective for asteroid detection also made complete information suppression nearly impossible. Distributed computing systems automatically create backup copies of observational data. International collaboration protocols ensure that discovery information flows to institutions beyond direct government control. Automated data sharing systems preserve fragments of observations in databases around the world. Most importantly, the scientific method itself creates redundancy. When something as extraordinary as 3I, Atlas, is detected, multiple independent observation systems automatically attempt to confirm and extend the discovery. Radio telescopes redirect to observe electromagnetic emissions. Optical telescopes attempt follow-up imaging. Space-based instruments try to capture additional data. The result is that while the official discovery can be classified and hidden, fragments of the truth survive in backup systems, international databases, and the memories of scientists who witnessed something unprecedented. These fragments paint a consistent picture that corroborates Dr. Chen's original observations. Radio telescope data from Australia confirms the structured electromagnetic emissions. Optical observations from European observatories document the unusual spectroscopic signature. Space-based infrared telescopes capture thermal data consistent with internal heat sources. None of these individual observations would be sufficient to prove the artificial nature of 3I, Atlas. But taken together, they provide compelling evidence that something extraordinary passed through our solar system in late 2024. The cover-up also reveals something important about institutional priorities when confronted with paradigm-shifting information. The decision to classify 3I, Atlas wasn't made by scientists or academics who understand the long-term importance of such discoveries for human knowledge. It was made by administrators and security officials whose primary concern is maintaining existing power structures and avoiding social disruption. From their perspective, the potential benefits of confirming extraterrestrial intelligence, advances in technology, perspective on humanity's cosmic significance, potential for peaceful contact, are outweighed by the risks of social upheaval, religious crisis, and the collapse of existing political and economic systems. This calculation reveals a fundamental assumption that ordinary people can't handle the truth about humanity's place in the universe. It assumes that confirming extraterrestrial intelligence would cause panic, social collapse, or other catastrophic responses that justify suppressing one of the most important discoveries in human history. But is that assumption correct? Would the confirmation of extraterrestrial intelligence really be more disruptive than continuing to hide evidence of our cosmic neighbors? And who has the right to make that decision for the entire human species? Tomorrow, we're going to explore what the classified data really reveals about 3I, Atlas, the specific evidence that made its artificial origin undeniable, and why that evidence was considered too dangerous for public knowledge. The complete picture that emerges from leaked documents and surviving observations is more extraordinary than even the most optimistic estimates of what interstellar visitors might represent. Thanks for joining me on this exploration of institutional secrecy and the suppression of scientific discovery. Sleep well, and remember, the truth has a way of surviving even the most sophisticated attempts to bury it. Welcome back to the story that challenges everything we thought we knew about our place in the universe. Today we're diving into the classified data itself, the specific evidence that made 3I, Atlas's artificial origin, undeniable, and forced governments to choose between scientific transparency and institutional control. What I'm about to share with you comes from leaked documents, backup data systems that survived the purge, and testimony from scientists who risked their careers to preserve fragments of humanity's most important discovery. This is the complete picture that officials decided was too dangerous for public knowledge. The evidence begins with something called trajectory analysis, APACE, basically mathematical detective work that reveals not just where an object is going, but where it came from and how it got there. Every object moving through space follows predictable paths governed by gravity, and when those paths don't match gravitational predictions, it tells us something extraordinary is happening. 3I Atlas showed trajectory anomalies from the moment of detection, but the full extent of its unusual behavior only became clear through detailed analysis of its path through our solar system. Using data from backup tracking systems that survived the classification process, independent researchers have reconstructed a flight pattern that can only be described as reconnaissance. The object's approach vector wasn't random. Instead of following the kind of hyperbolic trajectory you'd expect from natural debris ejected from another star system, 3I Atlas followed a carefully calculated path designed to provide optimal observation angles of Earth's major population centers. Picture this. Instead of zipping past the Sun in a straight line like Oumuamua did, 3I Atlas executed what mission planners call a gravity assist maneuver, using our Sun's gravitational field to alter its trajectory in precisely the way you'd need to establish a long-term observation orbit around Earth. But here's the really remarkable part. These maneuvers required active course corrections. Natural objects can use gravity assists, but they can't fine-tune their trajectories mid-flight. 3I Atlas made dozens of tiny velocity adjustments during its approach, each one precisely calculated to maintain its optimal reconnaissance path. The mathematics behind these corrections reveal engineering sophistication that goes far beyond anything humanity has achieved. We're talking about propulsion systems capable of making minute adjustments while traveling at interstellar velocities, navigation systems that can calculate optimal trajectories across billions of kilometers, and autonomous control systems that can execute complex maneuvers without real-time communication with their controllers. The spectroscopic evidence provides the second major piece of the puzzle. Every element in the universe has a unique signature in the light it reflects or emits, like a cosmic fingerprint that reveals what something is made of. Natural asteroids and comets show predictable patterns, rocky materials for asteroids, icy compounds for comets, sometimes metals from the cores of shattered planetoids. 3I Atlas showed none of these natural signatures. Instead, the spectroscopic analysis revealed materials that look suspiciously like advanced spacecraft construction components. High-strength aluminum alloys arranged in geometric patterns, titanium compounds in concentrations that don't occur naturally, rare earth elements organized in ways that suggest electronic components rather than random geological processes. Most tellingly, the object's surface showed signs of what engineers call engineered reflectivity, basically, materials designed to reflect or absorb specific wavelengths of light. This isn't something that happens naturally. It's a deliberate design choice that suggests active camouflage or stealth capabilities. The thermal analysis adds another layer to this technological picture. 3I Atlas was generating heat through mechanisms that can't be explained by any natural process known to science. Objects traveling through interstellar space for millions of years should be frozen solid, warmed only by starlight or radioactive decay of natural elements. But 3I Atlas showed thermal signatures consistent with 10 active power generation. Infrared observations detected heat sources distributed across the object's surface, in patterns that look like engineering systems rather than random thermal emissions. The temperature variations suggested internal compartments with different thermal management requirements, exactly what you'd expect from a complex technological system. Even more remarkably, the object's thermal output varied over time in ways that correlated with its proximity to Earth. As 3I Atlas approached our planet, its power consumption increased, suggesting that whatever systems it was operating required more energy when conducting detailed observations. The electromagnetic evidence represents perhaps the most compelling proof of artificial origin. Radio telescopes that managed to observe 3I Atlas before the shutdown detected structured electromagnetic emissions that can't be explained by any natural phenomenon. These weren't random radio bursts or the kind of electromagnetic noise you might expect from natural processes. Instead, 3I Atlas was transmitting organized signals with complex frequency patterns that suggest active communication or sensor systems. The signal analysis reveals something that should send chills down your spine. The electromagnetic emissions were clearly technological in origin, but they used communication protocols that don't match any human technology. We're looking at evidence of information processing systems that operate according to principles we don't understand, using techniques we haven't discovered. Most disturbing of all, some of the radio emissions appeared to be directed specifically toward Earth. These weren't omnidirectional broadcasts like you might expect from a malfunctioning system or natural phenomenon. They were focused, targeted transmissions aimed at our planet, exactly what you'd expect from a reconnaissance probe reporting its observations back to its controllers. The timeline analysis reveals operational sophistication that goes beyond simple data collection. 3I Atlas didn't just observe Earth passively. It actively adjusted its observation schedule based on what it found. The object's closest approach was timed to coincide with maximum electromagnetic activity from human civilization, Io need. Basically, when our cities would be most visible from space and our communication systems most active. The targeting analysis shows that 3I Atlas positioned itself to observe not just Earth as a whole, but specific regions that correspond to major population centers, military installations, and technological infrastructure. This isn't random scientific curiosity. It's systematic intelligence gathering focused on understanding human civilization's capabilities and organization. Perhaps most remarkably, the object showed signs of adaptive behavior. As Earth's rotation brought different regions into view, 3I Atlas adjusted its sensor orientation to maintain optimal observation angles. When communication satellites or other space-based assets passed near its position, the object modified its emissions patterns, suggesting awareness of human space activities and efforts to avoid detection. The propulsion evidence reveals technology that operates according to principles we're only beginning to understand. The micro-adjustments that kept 3I Atlas on its reconnaissance trajectory weren't produced by chemical rockets or ion drives like human spacecraft use. Instead, the object appeared to manipulate its trajectory through mechanisms that don't produce visible exhaust or thermal signatures. Advanced analysis of the velocity changes suggests propulsion systems that operate by manipulating gravitational fields or space-time geometry itself. This represents technology so far beyond current human capabilities that we don't even have theoretical frameworks for understanding how it might work. The stealth capabilities demonstrated by 3I Atlas reveal deliberate design for avoiding detection by primitive observation systems. The object's size, thermal signature, and electromagnetic emissions were all optimized to remain below the detection thresholds of most astronomical surveys. Only the extraordinary sensitivity of the Atlas network, combined with perfect timing and favorable observation conditions, made its discovery possible. But perhaps the most chilling aspect of the evidence is what it suggests about the scope of extraterrestrial reconnaissance activities. 3I Atlas wasn't a first contact mission or a casual scientific survey. The sophistication of its observation protocols, the precision of its reconnaissance orbit, and the depth of its intelligence gathering suggest that this was just one probe in a systematic study of human civilization that has probably been ongoing for much longer than we realize. The object's behavior patterns indicate familiarity with human space activities and communication systems that could only come from extended observation. This wasn't a probe stumbling across Earth for the first time. It was a reconnaissance mission conducted by intelligences that already understood human technological capabilities and knew exactly what to look for. The implications cascade through every aspect of human understanding. If extraterrestrial civilizations have developed interstellar reconnaissance capabilities of this sophistication, then our assumptions about cosmic isolation, technological development timelines, and the rarity of advanced intelligence require complete revision. More immediately, the evidence suggests that Earth has been under systematic observation by advanced civilizations that possess technology far beyond anything we've achieved. The stealth capabilities, autonomous operation, and reconnaissance sophistication demonstrated by 3I Atlas indicate that other probes might be operating in our solar system right now, conducting observations with technology advanced enough to remain completely undetected by our current observation networks. The cover-up of this evidence represents more than institutional secrecy. It's the deliberate maintenance of a false understanding of humanity's cosmic significance. The governments and agencies that classified 3I Atlas chose to preserve comforting illusions of human uniqueness rather than confront the profound implications of confirmed extraterrestrial intelligence. But the truth has a way of surviving even the most sophisticated suppression efforts. The evidence I've shared with you today comes from sources around the world, preserved in backup systems and protected by scientists who understood that some discoveries are too important to hide. Tomorrow, in our final episode, we'll explore what the 3I Atlas case means for the future of human cosmic awareness and why the next interstellar visitor might not stay hidden. The technological capabilities that detected this probe are spreading beyond government control, creating possibilities for citizen science and international collaboration that could make future cover-ups impossible. Thanks for staying with me through this incredible journey into one of the most important stories never told. Sleep well, and remember, we are definitely not alone. Welcome to our final episode of this incredible journey. Over the past week, we've uncovered one of the most important stories in human history, the discovery and subsequent cover-up of definitive proof that we are not alone in the universe. Today, we need to talk about what this means for the future and why the next 3I Atlas might not stay hidden. The case of 3I Atlas represents a turning point in human cosmic awareness, whether our institutions officially acknowledge it or not. For the first time in recorded history, we've encountered physical evidence of extraterrestrial technology operating in our solar system. The implications of that discovery extend far beyond astronomy or even science. They challenge fundamental assumptions about humanity's place in the universe and our readiness to join a galactic community we never knew existed. But perhaps the most remarkable aspect of this story isn't the discovery itself, but what happened afterward. The systematic suppression of paradigm-shifting information reveals institutional priorities that have nothing to do with advancing human knowledge and everything to do with maintaining existing power structures. The decision to classify 3I Atlas wasn't made by scientists who understand the long-term importance of such discoveries. It was made by administrators and security officials whose primary concern is avoiding social disruption, even if that means deliberately keeping humanity ignorant about the most important discovery in our history. This raises profound questions about who has the right to make such decisions for our entire species. When definitive proof of extraterrestrial intelligence is discovered, should that information be controlled by government agencies and military institutions, or does humanity as a whole have a right to know about our cosmic neighbors? The 3I Atlas case demonstrates that our current institutions are not prepared to handle discoveries that challenge fundamental assumptions about human cosmic significance. Instead of using this opportunity to advance human understanding and prepare for eventual contact with advanced civilizations, they chose secrecy and control. But here's what makes this story ultimately hopeful. The same technological capabilities that made the discovery of 3I Atlas possible are spreading beyond government control. The future of interstellar object detection doesn't depend on centralized systems that can be shut down by single institutions. Instead, it's evolving toward distributed networks that can't be easily suppressed. Citizen science organizations around the world are building their own observation networks using technology that's becoming more affordable and accessible every year. Amateur astronomers, with sophisticated equipment, can now detect objects that would have been invisible to professional telescopes just a few decades ago. International collaboration through internet-based platforms makes it possible to coordinate observations across multiple continents in real time. The same principles that made Atlas effective, wide-field surveys, automated detection, and distributed data processing, are being implemented by organizations that operate independently of government oversight. Private foundations, university research groups, and international scientific collaboratives are creating observation capabilities that no single government can control or shut down. Dr. Sarah Chen, the astronomer who first detected 3I Atlas, now works for one of these independent organizations. The foundation she joined is developing a global network of small telescopes specifically designed to detect and track interstellar visitors. Unlike Atlas, this network distributes its data immediately to institutions around the world, making it virtually impossible to suppress discoveries. The European Space Agency has announced plans for an interstellar object early warning system that will operate independently of NASA oversight. The Chinese space program is developing its own detection capabilities as part of their planetary defense initiatives. Private space companies are incorporating interstellar object detection into their satellite networks. What this means is that the next 3I Atlas, and there will be a next one, might not be suppressible. When multiple independent observation networks detect the same extraordinary object simultaneously, when data flows automatically to institutions around the world, when international collaboration makes suppression require coordination across dozens of governments, the kind of cover-up that hid 3I Atlas becomes practically impossible. The technological evolution of detection capabilities also means that future interstellar visitors will be detected earlier and studied in much greater detail. Improved sensitivity will spot objects while they're still in the outer reaches of our solar system, providing months rather than hours for detailed analysis. Advanced spectroscopic techniques will reveal compositional details that weren't possible with current technology. Space-based telescopes will capture observations that aren't affected by atmospheric interference. Most importantly, the protocols for handling extraordinary discoveries are being redesigned with transparency as a core principle. Scientific organizations are implementing automatic data release policies that make it impossible to suppress observations without international coordination. Legal frameworks are being developed that protect scientists who report unusual discoveries from institutional retaliation. The 3I Atlas case has also sparked renewed interest in searching for signs of extraterrestrial intelligence through more systematic approaches. If advanced civilizations are sending reconnaissance probes to study developing worlds, then our detection efforts should focus on finding technological signatures rather than just biological ones. New search programs are being designed specifically to identify artificial objects in our solar system. These include surveys optimized for detecting stealth technology, analysis techniques that can identify manufactured materials, and observation protocols designed to catch objects that might be actively avoiding detection. The implications extend beyond just finding more interstellar visitors. If 3I Atlas represents typical reconnaissance technology from advanced civilizations, then we need to fundamentally reconsider our assumptions about extraterrestrial intelligence and its relationship with developing species like humanity. The stealth capabilities and reconnaissance sophistication demonstrated by 3I Atlas suggest that advanced civilizations have developed systematic methods for studying primitive worlds without interfering with their natural development. This implies a level of cosmic ethics and long-term thinking that's both encouraging and humbling. From this perspective, the cover-up of 3I Atlas might be exactly what our cosmic neighbors expected. Advanced civilizations that have studied dozens or hundreds of developing worlds probably understand that most species go through a phase where institutional secrecy takes priority over scientific openness. They might even design their reconnaissance technology specifically to be detectable only by civilizations that have developed sufficient technological sophistication and scientific maturity. In other words, the detection of 3I Atlas might represent a test, not of our technological capabilities, but of our readiness to acknowledge extraterrestrial intelligence and begin preparing for eventual contact. The fact that we failed that test by choosing secrecy over transparency might delay our admission to whatever galactic community exists beyond our current awareness. But tests can be retaken, and the technological and social evolution of human civilization continues regardless of institutional preferences. The distributed detection networks being developed today, the international collaboration frameworks being established, and the growing public interest in extraterrestrial intelligence all point toward a future where cover-ups like the 3I Atlas case become impossible. The story of 3I Atlas also highlights the importance of preserving scientific data and protecting the scientists who make extraordinary discoveries. The fact that fragments of the discovery survived, despite systematic suppression efforts, demonstrates the resilience of the scientific method and the dedication of researchers who understand that some truths are too important to hide. The scientists who risked their careers to preserve evidence of 3I Atlas, the international collaborators who maintained backup observations, and the institutions that refused to participate in the cover-up represent the best of human scientific tradition. Their efforts ensure that when humanity is finally ready to acknowledge extraterrestrial intelligence, the evidence will still exist to support that acknowledgement. The technological signatures revealed by 3I Atlas also provide a roadmap for human development. If we want to eventually achieve interstellar travel and reconnaissance capabilities ourselves, we now have specific examples of what such technology might look like. The propulsion systems, stealth capabilities, and autonomous operation demonstrated by 3I Atlas represent engineering goals that could guide human technological development for centuries. More immediately, the 3I Atlas case demonstrates the need for institutional reform in how we handle paradigm-shifting discoveries. The current system, where extraordinary findings can be classified and hidden by small groups of officials, is inadequate for managing discoveries that affect all of humanity. Future protocols need to balance legitimate security concerns with the public's right to know about discoveries that fundamentally change our understanding of reality. This might require international treaties governing the disclosure of extraterrestrial contact, legal protections for scientists who report unusual observations, and institutional structures that prioritize scientific transparency over political control. The 3I Atlas case represents just the beginning of a larger transformation in human cosmic awareness. As our detection capabilities continue to improve, as our presence in space expands, and as our understanding of extraterrestrial intelligence evolves, we'll inevitably encounter more evidence of our cosmic neighbors. The question isn't whether we'll find definitive proof of extraterrestrial intelligence, profiling. The question is whether we'll be ready to handle that proof responsibly when we find it. The 3I Atlas case suggests that our current institutions are not ready, but the technological and social evolution of human civilization is rapidly creating alternatives that might be. The truth about 3I Atlas is still waiting in the dark corners where institutional secrecy tried to hide it. But darkness isn't permanent, and the light of scientific discovery has a way of illuminating even the most carefully guarded secrets. The next time an extraordinary visitor appears in our cosmic neighborhood, the world will be watching. Multiple observation networks will be tracking its every move. International collaboration will ensure that data flows freely across borders. Citizen scientists will be contributing observations from around the globe. And when that next visitor arrives, humanity might finally be ready to acknowledge what we should have recognized when 3I, Atlas, first appeared in our telescopes. We are not alone in the universe, and it's time to start acting like members of a galactic community that has been watching us all along. Thank you for joining me on this incredible journey into one of the most important stories never officially told. The truth about 3I, Atlas, challenges everything we thought we knew about our place in the universe, but it also opens possibilities for human development and cosmic awareness that are more extraordinary than any science fiction. Keep watching the skies, keep asking questions, and remember, the next great discovery might be just a phone call away. Sweet dreams, and welcome to the universe.